Hello and welcome back to Azure Terraformer. Today I have a very special episode. We are going to do one of my code reviews. One of my code ninjas, dankitch, has submitted a code review request to me, as is his right. And I'm going to go through and look at his code and give him some suggestions and try and figure out what he's doing, to be honest. So without further ado, let's get going. He's given me some idea about what's going on in the README here. The purpose of this Terraform configuration is to deploy the organization's underlying network infrastructure across multiple Azure subscriptions. The network setup defined within the connectivity directory provides the necessary network resources. Configurations can be referenced by various workloads. For example, domain controller resource, which is defined in the identity directory. If I look in this folder, okay, I see there's a folder for connectivity, and then I see a folder for domain controller, which I'm guessing that's going to be a domain controller. Now, looking at this, I don't know why we have underscores. I guess maybe he's using underscores to kind of put well-known files above the rest so that they don't blend in with the crowd, so to speak. I don't do this. I don't hate it, but I mean, it is kind of unnecessary. It's not a convention I follow, but I guess it works. I do follow conventions in the names of the files, like variables.tf, versions.tf. These are conventions that I follow. Typically, there's going to be a main.tf, which I've discussed as kind of like a relative, almost like the main method, But depending on how robust the module evolves into, the main might not actually have much in it. There may be, other files, and then main is really just like a place where shared resources go across the entire module. But here, we've got, this is clearly a root module, right? So we have a root module for this domain controller, and then we have a root module for this connectivity, I guess. I'm assuming this is a root module. Let's go check it out. Yeah, they're both root modules, and actually the connectivity is taking in, I guess three Azure RM providers. Very, very interesting. Clearly one is intended for the connectivity stuff, which is this module, and then one is for the identity stuff. So it will be interesting to see how this plays out. Hub network, when something is called hub, that usually sounds like a main resource. And guess what? I find what I would typically have in my main.tf, I find an Azure RM resource group, and I find a random string in there. What are we passing in as variables? Okay, a location. So one thing right off the bat, I probably wouldn't default the region. The region is something I feel like a consumer of this module should come into eyes wide open. They should know what region. And anytime you default an input variable, you're opening the door for the consumer of your module to just accidentally deploy to some region, right? Rather than forcing them to stop and think about what region am I going to deploy to, right? It's kind of an important decision. So I for important decisions, that are in that it manifest as input variables, I tend to want to make sure that, the user of my module is going to be thinking about that. So I would recommend not defaulting that. So that's one point of feedback right off the bat. Another, I understand what, typically I don't embed, we'll say context targeting parameters, subscription, and basically anything that provides the context of the cloud environment that you're targeting, right? In Azure, this is the subscription. It could be the identity that you're using to authenticate to Enter ID. I don't want to embed that in the configuration. I want that to be injected into the configuration through whatever Terraform execution mechanism I'm using. GitHub Actions, Azure DevOps Pipelines, whatever. But in this case, he's doing a multi-subscription deployment. So, he's kind of being specific about, what subscriptions. Now, there's a case to be made there, when your configuration needs to know about the context, because the context is actually driving the design of the configuration, then it probably makes sense to, do that. Management groups are a good example of that. If you set up Terraform and manage your Azure management groups using Terraform, you're probably going to have a bunch of subscription IDs at some point, dropped into, different management groups, right? So it because the association of those subscriptions is like what the configuration is all about. Now here, I think we'll have to, I'm going to hold my decision or hold my judgment about the appropriateness of using these, embedding the actual subscription IDs in here until later. Okay. Until I see what's actually going on here. But so far, okay, we got a multi-subscription thing going. I like the versions block. I think we're good. We got a Azure firewall rule collection. This is hitting on an Azure firewall, which I'm not quite seeing yet. We got a VNet, we got a PIP. Oh, and here's our firewall. Okay, so the firewall is actually in this hub network thing. Slight nitpick, I'd probably put the firewall stuff together. So if I'm going to have firewall rules in their own file, I'd probably just throw the firewall itself into the firewall rules file as well. To keep all the firewall stuff related, right? Now I get it. The firewall is going to be attached to the hub, right? But within the context of this module, the firewall is a thing that's going to get attached to this hub, right? But it's kind of like an add-on thing, right? Like we could have the hub without the firewall, right? So I think it makes sense to kind of like compartmentalize the firewall into its own file. That's just me. Makes sense to me. So looking at this, right? We have in the connectivity, we have an RG. I think we only have an RG. We have a VNet. And then we have a firewall. What else do we have here? We have a PIP and some subnets. I'm not too super concerned about that. We got a NAT gateway. I'll throw a NAT on here. What else? And we're basically associating the NAT gateway with the subnet. Okay. Giving the NAT a PIP. We're also associating the firewall to a subnet. So essentially we're kind of like just attaching, the NAT and the firewall to the VNet, right? Okay. We got a bastion. So I got to make this a little bit bigger here. We got a bastion host going on here. Okay. bastion. All right, super. And that's, of course, getting dropped into, this is kind of ugly. Let me clean this up a little bit here.
A few moments later.
So that's kind of cool. You know, we got these 3 components that are all part of our network. We got some route tables going on, which looks like it's related to, so this is actually hitting our RG network. So the identity services. So it looks like this is connecting to like maybe a VNet that's being provisioned in the domain controller, because we are using a network identity. Where would we reference that? So RG network identity services. Is that? Yeah, so we have an RG hub network. Wouldn't that be a data source though? Or are we provisioning an RG as well? Oh, interesting. So the plot thickens. We are actually also provisioning another RG down here for the identity services. I'm just going to call it RGID and RG hub, right? And so here, this is where we are creating the stuff that's in a different subscription. So I almost want to like call this out. So we have a VNet that's in this other subscription. So everything I've drawn so far was previously just using the default provider, right? Except for this stuff. And actually I kind of screwed up here. This RG is in a different subscription, right? It's in RGID. So all this stuff, it's really just a VNet, right? Is in that thing. We got a route table. Okay, give you that. And I consider this all essentially VNet configuration, right? A route table and the association of that route table to a VNet, via the subnet. That's all the VNet. There's nothing else going on here. Now here's the fun part, right? So we have a virtual network peering that's hitting the connectivity, and then we have the identity, right? So we basically have a peering association that connects, and I gotta play with the colors here a little bit. So we got a peering here. And then these guys kind of reference each other, right? So now this is interesting. Okay. So now typically, like with a hub network, you're going to want to potentially scale this out to attach many spokes to that hub. I mean, that's kind of why they call it a hub and spoke, because the hub, there's a one hub and then there's many spokes, right? It's a one-to-many kind of thing. So the idea would be that we would attach many of these spokes. Now, the way that we're doing this, right, in order to make this work, like the way I would scale this out would be, I would have to go declare a new provider in my connectivity module, and I would declare a new provider to a different subscription, and then I would stamp out, yet another resource group like this, right? So basically, I would kind of have to do n of these, right? I'm gonna create RG foo. Okay, this is my next spoke that I'm gonna add. I'm gonna have to create another VNet. can't spell. With appearing, right? And then I'm going to have to create another pairing over here in this subscription in order to connect these guys together, right? So, and by the way, all of this is in one Terraform workspace, right? So I've got N subscriptions that are going to be deployed to this thing. Now, I'm presuming Echo Foxtrot 8. What is this? Echo Foxtrot 8. Okay. So whatever's in this domain controller business, right? To make this like accurate, right? This domain controller business is actually in the identity resource group, right? I'm sorry, in the identity subscription. My bad. So this stuff. Yeah, let me just get rid of that. There we go. All right. So now, what do we got in here? We're referencing the VNet. So we have a data source, right? That references this VNet over here. And then we provision a resource group that's going to host our domain controller. Okay, so we have an RG, and we have let's just say a VM, and all the stuff that surrounds that virtual machine extension. Blah blah blah. Run a PowerShell script. Wonderful, right? So basically this is what's happening. Now, the structure of this, is going to be problematic going forward because basically this hub module has to know about every single thing that there is, right? So if you look at this, right, what we're doing is, we've got the hub, but the hub has to know about the identity, has to provision some stuff for the identity guy, and then it has to provision stuff for this guy, and then it has to provision stuff for this guy, and then it has to provision stuff for this guy. And then what do? We set this guy up and we point it at this thing, right? And then we set this guy up and we point it at this thing. And so this creates multiple touches that we have to do, right? Now, I'm trying to think of what I would call this. This is in my opinion an anti-pattern in Terraform, right? In infrastructure as code, because it creates a tight coupling between the hub and all of the extensions, right? Each of these little spokes, right, is, you can think of as like an extension. And in software development, we do this all the time, right? Like when you implement modular systems, and I know I'm conflating terms here, right? Not talking about Terraform modules. I'm talking about just legit software engineering modularity, where you have the ability to kind of like hot swap, software components like parts in, right? Think about that, like a dashboard is a great example of this, like Grafana or Power BI or something like that, right? The dashboard is the hub, right? And each little panel within that dashboard is like a spoke, right? The beauty of and the way all of these dashboard systems work is that they don't mess around in the implementation details of every panel. The hub or the dashboard just provides a common set of functionality, right, that lets these panels get attached, and then the panel can do whatever it wants, right? Now, this approach, that we're looking at here, the way that like this is being designed, right, is that basically we have a dashboard that has hard-coded spots for every panel, right? That means that every time we want to add a panel, every time we want to create a new panel, then we have to go modify the hub, right? And it becomes like the octopus thing that everybody touches. So what I would rather see is a clear delineation of like what is the hub responsible for, right? So the hub can definitely have, like a VNet, right? So the hub we can't get away from the fact that these spokes are in some way dependent on what's in the hub, right? But we can, if we invert that what the tight coupling that we have, and we make it, more loosely coupled, right? Then these spokes can attach and detach from the hub with limited, touching of the hub. Like the hub should not change, right? So basically that would mean that the spoke down here would just need to have some reference to the hub, right? And so we have this ability to create a peering connection between each spoke of the hub. And so now you can see that all of the implementation detail of every spoke stays within that spoke. So in our example, right, what do we have? We had this identity thing, this domain controller. So rather than having the resource group for the spoke being provisioned within the hub, like we did here, right? The spoke is going to have the resource group, it's going to have the VNet, it's going to have the VM, right? With that extension and the PowerShell and all that stuff happening in it. But it's also going to have a pointer peering back into the hub with the hub, right? So the spoke is, in a sense, responsible for attaching itself onto the hub. Now, depending on your identity and access management, the security boundaries that you want to set, you might have to think through this a little bit, because the spoke shouldn't, like if these are in different subscriptions, you may not want that spoke to have so much privileges in the hub subscription, right? So you'll probably have to think about like having a custom, like a custom role definition, right? That would be granted, to each spoke, to each identity that's provisioning each spoke, right? And that custom role definition would grant that identity a very, very limited permissions within the hub, right? Essentially, you are allowed to create a VNet peering, with this VNet. The hub the hub VNet, right? You can create VNet peerings, you can remove VNet peerings, you can have a great old time, right? And that essentially will poke a hole, right, in the security boundary that will allow those spokes to attach and detach themselves. So if the spoke wants to eradicate itself from existence, like we do a Terraform destroy, then the spoke goes away and it removes and it cleans up its peering from that hub. And the hub has no idea that this is happening, right? So we don't have to do anything. So it creates a very, very clean separation of concerns between these different infrastructure as code solutions. And ultimately, it creates an increased level of stability in the hub, which is what you want, because now the hub really doesn't have to change ever, right? The hub only has to change when we change things about the hub, such as firewall stuff happening in the hub, And then when we add additional spokes, the only thing that has to change is the VNet peering, right? To link that spoke with the hub. So, I think that's probably the biggest design change that I would make to this solution. I mean, what this is also going to do is the connectivity, it's going to radically simplify this connectivity module. The connectivity module no longer will need to have the subscription details embedded within it, right? We would probably just use, this default provider, and we would delete these right here. But then the spoke, likewise, would have a default provider. You can get rid of this because each spoke is going to know what subscription it wants to be in. But you probably need to have a provider declared for the hub, right? Inside the spoke. And then that provider is used for one resource alone. And that is that VNet peering, to that hub, within that hub subscription, right? That would simplify this a lot. Other things, just kind of cruising through here. You have to decide if you want these things like this to be input variables or not. I think a lot of times, like a lot of people think like, especially traditional developers, they come from traditional development and they think, I can't actually, string constants are bad, right? But when you're working with Terraform, string constants are actually okay, right? Because string constants represent configuration that you don't expect it to ever change, right? Like you don't need to dynamically change, right? So if your application uses port 80 and port 443 and that's it, just roll with that, right? You don't need, dynamic, parameters there, right? That's all you got. Now, I would CIDR blocks. I would definitely consider extracting that as some way of building that CIDR range so that can be extracted, because you don't want to have overlapping CIDR ranges, right? So this having hard-coded CIDR blocks can definitely impact the reusability of your module to stamp it out. So I would highly recommend considering that. And then looking down at this PowerShell script, so that's interesting. So he's got a PowerShell script here that's got these params coming in. And then you let's go look at this. So now we've got, whoa, we got some pretty crazy stuff going on here. So we're doing a lot of HCL gymnastics in order to pass these in as parameters, right? When we could probably we got to put them in. We're doing a template file, right? Template file. What is a template file? Oh, so we're template filing the PowerShell script and we're plugging in these input variables, but then we are we're passing them as parameters here, right? I don't get that. Let's look at this. Yeah. So this is kind of unnecessary, right? Whoa, something's wacky. Yeah, so it looks like and I can't remember if this is the parameter syntax. I get the feeling that I thought you needed squigglies for template file. Yeah, you need squigglies, right? You need dollar squiggly in order to get this working. So I'm not confident that this stuff is actually like doing anything, because I don't see any place in here. It's funny, my last search history was Star Wars. Just showing my colors, man. Okay. Yeah, so I think template file is just an unnecessary complexity. I don't see this adding any value, really. Now, I mean, template file wouldn't be a bad idea. If you're gonna do a template file, then you definitely don't need to go through the hassle of like also doing the parameterization here, right? It's like we have two competing forms of parameterization. One is using template file, and then one is like actually trying to pass in those HCL symbols as parameters to the PowerShell script. Probably unnecessary, and it definitely unnecessary. So I would probably just ditch the params and actually use template file, right? And just drop those values in there. You can just in like, if this PowerShell script is not ever going to be used by any solution outside of this, then you don't have to worry about like maintaining compatibility. Because I understand why people like that are going to use this PowerShell would probably want it to be parameterized. But if you're going to ninja PowerShell in using a virtual machine extension, then you can use template file to drop in these symbols, the values of these symbols into the file, and then at that point you just declare environment variables, set the value to the templated symbol, and template file will jam in the hard-coded values, right? And essentially you've like hard-coded them into that script, right? Which will then immediately get base 64 encoded, and then like executed via the virtual machine extension. So that's probably what I would do, and then it would kind of clean this up quite a lot. Yeah. And one thing I can't remember, is it canon to use the template file data source, or should you just be using the function? Let's go look. Template file, because I think one is, yeah. So back in I sometimes forget this stuff too, but like back in the olden days, there was no template file function. So you had to use this data source, but nowadays, like you can just use the template file function and it does all of this stuff. So I would probably just, instead of using the data source, I would just use the template file function, use a local, and get rid of those params in the PowerShell to make the PowerShell like easier to read, much, much simpler. And drop that stuff in there. Yeah. And I guess lastly, like, let's talk about naming conventions, right? I mean, we have a little bit of a mixed bag here. We've got some Pascal casing, which is very much PowerShell-y. And then we have, some capital name Pascal casing meets underscore separated Terraform stuff. Input variables, in my opinion, should be lowercase, should be underscore separated values. That's it. no Pascal case, no camel case. That this is a good one. This is a good one. This is a good one. You know, that's how it should be. Anyways, I hope you enjoyed this code review. Dankitch, thank you so much. One of my longest supporters. Really appreciate all your support, man. And keep these code reviews coming. Had a good time with this one. Keeping me on my toes with the multi-subscription, multi-provider code review. It's pretty fun. And hope you guys enjoyed me dropping into the whiteboard. Let me know what you think in the comments below. And if you are enjoying this content, please smash that like button and consider subscribing to the channel. It really helps out a lot. Also, consider channel membership and either announcing yourself to the world as an official Azure Terraformer or joining Dankitch as a code ninja and submitting your own code review for me to absolutely torch. Just kidding. We're all friends here in an upcoming episode. Anyways, thank you so much. This is the Azure Terraformer signing off.